Hello students and welcome to my channel Maths Hub. So today in this video, I'll talk about the applications to the RLC circuit. So by now, I hope you have seen my earlier videos on how to solve differential equations. And now we are in a stage to solve the applications to RLC circuit. So first of all, let us understand what is the problem, what is the RLC circuit, right? So in any electrical circuit, what happens? It consists of a resistor R, then which is whose units are in ohms. It consists of a capacitor C, whose units are in farads, and an inductor L, whose units are in henries. And there is a total electromotive force in volts, which is usually a battery or a generator, which is connected all in series, right? What else is in that circuit? A current I is flowing through that circuit and it is measured in amperes, and the charge Q on the capacitor is measured in coulombs, right? So you can get different combinations of the circuit. So it can have, when all the three components are there, it is called an RLC circuit, right? So you can have any two combinations also. There can be R and C present, there can be L and C present, there can be R and L present, right? So any combination of the circuit can come, right? So we will do all together all the three, and then I'll tell you that if any one of them is missing, then how the differential equation is to be modeled. So the circuit seems like this. So this is the symbol for the resistor. This is the symbol for the capacitor. This is the symbol for the inductor, and this is the symbol for the electromotive force, right? So in some cases, the electromotive force can be a constant quantity. In some cases, it might be a variable, right? Now, how do we model a differential equation when the RLC circuit is given to us? So let us try to understand that what is the voltage drop across all these things through the resistor, through the inductor, through the capacitor, and then we will try to frame the differential equation, right? And we will use the Kirchhoff's law that you have studied in physics to compile the modeling of this differential equation. So first of all, let us understand that what are the potential drop across these circuits. So the potential drop across the resistor, so I'll just write over here, the potential drop across R is, so this is again physics, across R is I into R. I is the current flowing through the circuit in amperes. The potential drop across the capacitor C is Q by C, and the potential drop across the inductor L is L di by dt, right? So these are the potential drop. Now, according to the Kirchhoff's law, the potential drop across all the three components, that is RLC, should be equal to the total electromotive force. And the total electromotive force that is given to us in the circuit is E, right? So accordingly, we get IR plus Q by C plus L di by dt should be equal to the total electromotive force, that is E. So that becomes our first equation. That is, I've just rearranged the terms. So you can see L di by dt plus IR plus Q by C is equal to E. Now it's written ET because ET can be a constant. If it is a constant, we will not write T here. And if it is depending on some function T, then we have written it as ET, right? Now you have solved those differential equations when the dependent variable is a single quantity in the equation, right? So here you can see that we are having I and Q. Both are dependent, right? So we have to convert either the entire equation in terms of I, or we have to convert the entire equation in terms of Q, right? Now, do we have a relationship between the current flowing through the circuit and the charge? Yes. What is that relationship? The relationship is I is equal to dt by dt, right? So we will take care of this and we will try to convert equation 1 either in terms of charge, or we will try to convert it in terms of the current, right? So we have seen that we are using these symbols. Q is used for charge, I is used for current, L is used for inductance, R is used for resistance, C is used for capacitance, and E is used for the electromotive force, right? So now let us try to convert the first equation in terms of either I or in terms of Q. So we have seen that I is equal to dq by dt, right? So here in this equation, if I replace I with dq by dt, what will I get? I can see the first term becomes L d by dt of I is replaced with dq by dt plus R into dq by dt plus q by c is equal to E, right? Now what is d by dt? It is L d square q by dt square plus R dq by dt plus q by c is equal to Et, right? So here you can see that the entire equation has been converted in terms of Q, and this is a second order differential equation where L, R and C, they are all constants. So you can see this is a second order differential equation with constant coefficient, and we already know how to solve it. So if it is equated to 0, if the electromotive force is equal to 0, then it will be called a homogeneous second order linear differential equation. And if Et has some value, either a constant or some functions of t, then we will say that it is a non-homogeneous equation, right? Now this is the equation that is in terms of Q. So here you can see that I've just replaced it, and this is what we are getting. So this equation is purely in terms of Q. Now, how can we convert this equation in terms of I? So you can see that this is already in terms of I, this is also in terms of I. Now, Q has to be replaced in terms of I. So if I take the derivative of the first equation, what will I get? L is constant. So we will have d2I by dt square plus R, derivative of I is di by dt plus 1 by c is constant, and when I take the derivative I get dq by dt, and on the right hand side if E is constant the derivative will become 0, and if E is a function of t then the derivative will be d by dt of Et, right? Now can you see that we can replace now dq by dt with I, right? So the equation gets converted to L d2I by dt square plus R di by dt plus 1 by c times I is equal to d by dt of Et. So this is the second equation that has been converted in terms of the variable I. So according to the nature of the problem, if the question tells you to calculate charge, you can use this differential equation. If they tell you to calculate current, you can use this differential equation. But perhaps mostly in some the questions it's being used, they tell you to calculate both charge and the current, right? So you can use either of the equations, and if one of them is known, you can calculate the other. So normally we solve this type the equation that is in terms of Q, because once Q is known, we can take its derivative and we can calculate I, right? So this is what the second slide is telling us. So here we have taken the derivative of this equation, and this is what we get. Right? So I've told you how to model an RLC circuit either in terms of Q or in terms of I. Right? Okay. And then you know that when we have some constants in our answer, we can always eliminate it with the help of the initial conditions. So those initial conditions will be already provided to you in the question. Right? So now let us try to solve this question. A series circuit consists of a device where L is equal to 1 Henry, R is equal to 20 ohms, C is equal to 0.002 Faradays, and E is equal to 12 volts. If the initial charge and the current are both 0, find the charge and the current at time t. So here you can see that the question is demanding you to calculate both charge and the current, right? And what are the initial conditions given to us? That both the initial charge and the current are 0. That means Q initial means at t equal to 0 is 0, and similarly I at t equal to 0 is also equal to 0. So let us try to frame the equation. So the equation says L d2q by dt square plus R dq by dt plus q by c is equal to E. This was the first equation that we had, right? If you forget also the second order differential equation, you can quickly write the Kirchhoff's law, the potential drop across L plus the potential drop across R plus the potential drop across C should be equal to E. And then we know that I is equal to dq by dt. So you can just quickly replace it and you will find that we get this equation, right? So this is your mental work. Now, what is to be done further? So now you can see that in the question, all the values of L, R and C are given to us. So let us substitute. L is 1 and you should be taking care of the units. They should be, L should be in henries, R should be in ohms and C should be in Faraday, right? So L is 1, so this term is simply d square q by dt square. Then we have R. R is 20 ohms. So it is 20 into dq by dt plus 1 by C. So let's quickly calculate what is 1 by C. So we have 0.002. So this is basically 1000 by 2. So that is 500. So we get 500 Q is equal to 12. So you can see that the electromotive force is constant, right? Now from here, we can write this in an auxiliary equation form. D square plus 20D plus 500 times Q is equal to 12. So this is a non-homogeneous differential equation and by now we know how to solve it. So first of all, let us convert this into an algebraic expression. So we will get m square plus 20m plus 500 is equal to 0. So what is m? M, you can use the quadratic formula, minus b plus minus b square, that is 400 minus 4a into c. So 4 into 500 is 2000, right? Yeah, divided by 2a, so it is 2. So that turns out to be minus 20 plus minus, this will be minus 1600, so it is 1600 root minus 1. So 1600 will become 40 iota by 2. So that is how much? You divide it by 2 and we get the result as minus 10 plus minus 20 iota, right? So from here we need to calculate Q. So the complementary solution of charge is e raised to power minus 10t C1 cos 20t plus C2 sin 20t, right? Now let's calculate the particular integral. So the particular integral is 1 by, the auxiliary equation said it was d square plus 20d plus 500, and on the right hand side we have 12. So I can take out 12 as a constant out and I can write this as e raised to power 0t, because e raised to power 0t is same as 1. So when you replace d with 0, you'll get 12 by 500. So this is 12 by 500, right? And this will get reduced to, you can cancel it with 2, so it is 6 by 250. And then when you further reduce it by 2, it is 3 by 125, right? So we get our values of Q as, I'm writing here with a different pen. So Q is QC plus QP. So it is e raised to power minus 10t into C1 cos 20t plus C2 sin 20t plus 3 by 125. Now I need to calculate the values of these constants as well as I want the value of the current also, right? So we know that I is dq by dt. So let us first calculate I. I is dq by dt. So let's take the derivative of this expression. E raised to power minus 10t constant. Let's take the derivative of the bracketed term. So we will get minus 20c1 sin 20t plus 20c2 cos 20t, right? Plus, now we take the derivative of e raised to power minus 10t, so that will become minus 10 e raised to power minus 10t into c1 cos 20t. Now the second bracketed term will remain same, plus c2 sin 20t, right? Now let us put the initial conditions and let's try to find out the values of the constant. So it's given that q at 0 is equal to 0. So what do we get? Let's put t equal to 0. So e raised to power 0 is 1. Then we have c1 cos 0. So we will be left with c1. c2 will vanish, plus 3 by 125 is equal to 0. So from here, c1 comes out to be minus 3 by 125. Now let's work out for I. Now it's given that I at 0 is 0. So let's put I equal to 0. So this term is 1. This term is gone. We are left with 20c2 minus, this term is 10 times E is 10. Then we are done with the sine term. Sine 0 is 0. We are left with C1. So we get C1 is equal to 0. So from here, what is C2? C2 is basically 10, 20 C2 is 10 C1. So you will get C1 by 2. So C1 we have already written it as minus 3 by 125. So C1 by 2 will become minus 3 by 2, right? So once we know the values of the constants, we can put it back in Q and C. So we get the expressions for Q and C as Q comes out to be, so I'm just writing down the final answer. So Q comes out to be e raised to power minus 10t C1. C1 is minus 3 by 125 cos 20t plus C2. So that is minus 3 by 250 sin 20t plus 3 by 125. And what is I? I is e raised to power minus 10t C1 minus 20 C1. So when I replace C1 there, I'll get 20 minus 20 into minus 3 by 125. So 5 fours are 5 25s are. So that is 12 by 25 sine 20t, and then I have 20 times C2. So it is 20 into C2 is minus 3 by 250. 0 gets cancelled and I get minus 6 by 25 cos 20t. Then we have minus 10 e raised to power minus 10t, and then we have C1. C1 is minus 3 by 125 cos 20t plus C2. C2 is minus 3 by 250 sine 20t, right? So that comes out to be our answer, right? So you can see how we model the equation. Then it reduced to a second order differential equation, either a homogeneous or a non-homogeneous form. And then using the same methods, we solve it. And then we take the help of I as dq by dt. We take the derivative, we put in the initial conditions, we solve for the constants, and then we finally get, right? So I hope you have understood this question. So do try the next problem. So the working was given here, so you can just get, you can try this exercise, find the charge and the current at time in the circuit if R is equal to 40 ohms, L is equal to 1 henries, and capacitance is 16 into 10 raised to power minus 4 faradays, and E is 100 cos 10t. So try this problem and do let me know if you were able to solve it in the comment section, right? So thank you so much for listening. And those of you who like the video, just hit the like button. And those of you who have not subscribed my channel, do subscribe my channel to get the latest updated video. Believe in yourself and you will be able to